have you on Fascinating Frontiers, episode 102. It's June 15th, 2026. New week, new discoveries. Let's see what's happening. Tiny red dots scattered across the early universe have turned out to be black holes cloaked in dense gas. James Webb Space Telescope spectra reveal that one of these mysterious early universe red dots is a compact object whose X-rays are absorbed by surrounding gas. The object's true nature only appears once the dense cocoon is accounted for in the data reduction. Researchers had wondered whether these abundant, bright sources challenge standard galaxy formation models. The new observations instead place them on the evolutionary track of growing supermassive black holes. Follow-up programs will target additional red dots to test how common this disguise is at high redshift. The James Webb observations of one little red dot show a compact object whose X-ray output is almost entirely absorbed by surrounding gas, leaving only a red glow at longer wavelengths. This disguise explains why earlier surveys missed the true population of growing black holes at high redshift. The same technique can now be applied to the hundreds of other red dots already cataloged, revealing how common such embedded phases were when the universe was under 2 billion years old. What fraction of today's supermassive black holes experienced a similar shrouded growth stage remains unknown. From hidden early universe engines to a very different kind of hidden motion, we turn to Venus's famously sluggish spin. Venus rotates once every 243 Earth days, so slow that a person walking westward at 6.5 kilometers per hour can match the planet's spin. The steady pace holds the sun exactly on the horizon, turning sunset into a permanent view. Planetary scientists note this works only because the atmosphere and surface move together at that latitude. The effect ties into new giant impact simulations that could explain the slow retrograde spin. If Earth rotated as slowly as Venus, a single day would last 243 of our years, stretching sunrise to sunset across more than 2 centuries. On Venus, the surface itself creeps eastward at only a few kilometers per hour, so a walker moving westward at 6.5 kilometers per hour can stay exactly beneath the setting sun. That speed is roughly the pace of a brisk human stroll on Earth, yet it matches an entire planetary rotation. The geometry works because Venus's thick atmosphere and rocky crust turn together, letting the walker keep the terminator fixed without fighting winds. We can watch the same principle in fast forward during a lunar eclipse when Earth's shadow creeps across the moon at a few kilometers per second. No one yet knows whether Venus has always spun this slowly, or whether a single ancient collision flipped and braked it into the present state. While Venus offers a ready-made horizon chase, Europe is preparing to chase heavier payloads into orbit. The European Space Agency will stream the next Ariane 6 flight, which carries an upgraded booster configuration. Engineers have increased thrust and propellant capacity to handle heavier payloads on future missions. The launch targets a geostationary transfer orbit insertion that tests the vehicle's expanded performance envelope. Ground teams at Europe's spaceport in French Guiana have completed final integration checks. Watchers can follow the countdown and separation events on the agency's live feed. As Europe tests expanded launch capability, another long-running European mission receives extra time to keep working. The European Space Agency approved a 3-year extension for the Characterizing Exoplanet satellite, allowing continued transit photometry of known worlds. The spacecraft's 30-centimeter telescope has already refined radii and densities for dozens of planets. Mission scientists plan to target systems where atmospheric follow-up with James Webb or ground-based instruments is feasible. The extension keeps the observatory operating alongside newer facilities rather than retiring it early. Data releases will continue on the same public archive schedule. While Cheops keeps watch on known worlds, a new concept aims to explain why some worlds look the way they do. NASA's Early Evolution Explorer concept would fly a small telescope to measure precise radii and masses of planets near the 1.8 Earth radius gap. The mission aims to distinguish whether photoevaporation or core-powered mass loss creates the observed divide between rocky super-Earths and gaseous sub-Neptunes. A single year of survey data could yield hundreds of new mass-radius pairs across a range of stellar types. The draft proposal outlines a 3-year prime mission with an extended phase for atmospheric characterization. From measuring planets we already know to harvesting what future explorers might use, we look at Titan. A NASA-supported assessment concludes Titan offers unmatched stores of hydrocarbons, water ice, and nitrogen for future explorers. The analysis compares these reserves against the Moon and Mars, where volatile supplies are more limited. Researchers modeled extraction methods that could produce propellant and life support consumables on site. The study emphasizes that Titan's thick atmosphere and surface lakes simplify some logistics compared with drier bodies. Next steps include laboratory tests of cryogenic processing techniques using simulated Titan regolith. While Titan offers future resources, closer to home, a millisecond pulsar offers a near-perfect laboratory. China's 5E 100-meter aperture spherical radio telescope found a millisecond pulsar spinning 220 times per second around a companion star. The orbit's eccentricity is so low it ranks among the most circular measured, preserving a billion-year record of tidal evolution. Timing data reveal the two stars have exchanged mass without disrupting the near-circular path. Continued monitoring will tighten constraints on the companion's mass and the system's age. The discovery adds a clean laboratory for testing general relativity in strong fields. From one ultra-stable binary to the subtle imprint an entire galaxy leaves on gravitational waves. A new study shows the Milky Way's rotation imprints a subtle directional pattern on the nanohertz gravitational wave signal from millions of binary stars. Future space-based detectors must subtract this foreground to avoid biasing measurements of the overall wave background. The signal arises from the galaxy's stellar population rather than rare catastrophic events. Modeling the spin component improves subtraction accuracy for both galactic and extragalactic contributions. Analysts will apply the correction once LISA begins collecting data in the 2030s, from foreground subtraction to missing elements in interstellar chemistry. Diffuse interstellar gas contains the expected amount of sulfur, yet cold molecular clouds show only 1% of that abundance. Researchers propose the element locks into icy dust grain mantles that current observations cannot easily penetrate. Laboratory spectra and new chemical networks are being tested against ALMA maps of sulfur-bearing molecules. The next round of observations targets edge-on clouds where grain mantles may be directly sampled. Laser-driven light sails must withstand extreme acceleration while maintaining stability over interstellar distances. Thermal expansion, Poynting-Robertson drag, and sail wrinkling each impose limits not captured in earlier idealized models. Engineers are now running finite element simulations that include realistic material properties at speeds above 0.1 times the speed of light. The updated calculations show that sail mass must increase to survive the journey, reducing the payload fraction. Laboratory tests of candidate metamaterials are scheduled for the coming year. A moon-sized body striking Venus at high speed and oblique angle could have reversed and slowed the planet's spin to its present state. The scenario reproduces both the retrograde rotation and the 243-day period without requiring later tidal evolution. Hydrodynamic simulations show the impactor's core would merge, while its angular momentum dominates the final rotation. The model also predicts a temporary debris disk that could have influenced early climate. Refined crater statistics from future Venus orbiters will test the timing of such an event. The UK Space Agency signed an agreement with VAST to study a mission that would send amputee astronaut John McFall to a commercial space station. The study will examine physiological effects of long-duration flight on a prosthetic limb and cardiovascular system. McFall, a former Paralympic sprinter, would become the first person with a physical disability to live aboard an orbital platform. Data gathered could inform future crew selection criteria for commercial operators. A final go or no-go decision is expected after the initial feasibility report. The Hubble telescope captured elliptical, spiral, and lenticular galaxies within the cluster, along with faint gravitational arcs from more distant background sources. The arcs trace how the cluster's mass bends light from galaxies formed when the universe was less than half its current age. Photometric catalogs from the image will feed into studies of galaxy evolution inside dense environments. On June 15, Mercury stands 25 degrees east of the Sun and shines at magnitude 0.5 in the evening sky. Observers can spot the planet half an hour after sunset, before it begins its rapid return toward the Sun. The elongation offers the best northern hemisphere evening appearance of the year. Binoculars or a small telescope will show the planet's small disk and phase. Dark skies around the June 14 new moon provide optimal conditions for spotting the 3 planets in the western evening sky. Mercury, Venus, and Jupiter form a changing triangle that tightens through the month. Observers can track the planet's relative motions night by night without interference from moonlight. The configuration also places several bright summer constellations in good view. Before we go, keep an eye on the next round of James Webb follow-up observations, targeting additional little red dots. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. And before you go, this show is part of the NARA Network, a family of daily podcasts covering tech, science, markets, and more. If you enjoyed today's episode, give Planetarian Daily a listen. Daily breakthroughs in science, health, and longevity. You can explore the whole lineup at neuranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly